Guys, I'm back with another question paper, which is October number 2012, paper 22. So, what does the paper 22 mean? Of course, it's the paper 2 structure question, and the second two is the variant. So let's read through the instructions first. These are all simple. So the most important one is that the data is regarding the data booklet here. Regarding the data booklet, so you have to be provided a data booklet. So the data booklet looks like this. Let me just show it to you. Yeah, it looks like this. It looks more or less like this. Okay, it's a bit upside down because I'm clicking this video picture, so I'm gonna just click this picture. It'll be inverted, right? Oh, oops, so it's not correct. Okay, anyhow, where did that go? Yeah, anyhow, so you must be provided such a data booklet. And okay, so let's go on. So zinc is an essential trace element which is necessary for the healthy growth of animals and plants. So zinc deficiency in humans can be easily treated using zinc salts as dietary supplements. So that's what your doctor recommends you to eat whenever he says that remember you've got zinc deficiency. So one salt which is dietary supplement is hydrated zinc sulfate, ZnSO4xH2O, which is a colorless crystalline solid. Crystals of zinc sulfate may be prepared in a school or college laboratory by reacting dilute sulfuric acid with a suitable compound of zinc. So if you have dilute sulfuric acid and a suitable compound of zinc, you will just mix them together and you get zinc sulfate. Give the formula of two simple compounds of zinc that could each react with dilute sulfuric acid to produce zinc sulfate. So you can say zinc sulfate and zinc chloride. Okay. Okay. So that's about it. So they gave a long amount of text just for a 2-mark question, which was oh no, not zinc sulfate. Sorry, I did it wrong. Wait a minute. I wanted to write down zinc oxide. Zinc oxide. Okay. A simple experiment to determine the value of X in the formula ZnSO4xH2O is to heat it carefully to drive off the water. So you need to heat it carefully. Just make sure you don't heat it too much that it melts. So a student placed a sample of the hydrated zinc sulfate in a weighed boiling tube and reweighed it. He then heated the tube for a short time, cooled it, and reweighed it when cool. The process was repeated 4 times. The final results are as shown below. Mass of empty tube 74.25 grams. Mass of tube and hydrosols. Mass of tube and salt after fourth heating. Why was the boiling tube heated, cooled, and reweighed 4 times? To avoid experimental inaccuracies. Oh, another thing, I don't think you can use zinc chloride there. Yeah, I just realized you can't use zinc chloride. You have to use zinc hydroxide. Zinc hydroxide will be actually safer. Just make sure you don't write zinc, okay? To avoid, or maybe as a safer precaution, we like to write to ensure that all water had been evaporated. Okay. So calculate the amount in moles of the anhydrous salt produced. Okay, so you must remember that they have asked you in moles. So mass. So first we'd like to write down the mass, which is 77.97 minus 76.34. In anhydrous means that it doesn't contain any water. So what should I do with the 74.25? It doesn't matter actually. Okay, it doesn't matter because the mass of the tube, it's always the mass of the tube plus hydrated salt. So Mt plus Mh minus, it's like this, right? Mass of the tube plus mass of the salt, or mass of the anhydrous salt. So it becomes mass of T plus mass of the hydrated salt minus mass of the T plus mass of the anhydrous salt. Sorry, not plus. Minus mass of the anhydrous salt. When you expand the minus, you must remember that this and this will go off. So you're right left with what you want, which is this one minus this one, right? So that's the mathematical proving. Okay, 1.63 grams. So then you need to calculate MR of zinc sulfate, right? Zinc is zinc sulfate, right? ZnSO4, which is equal to zinc is, you see here is when the data booklet comes in. A copy of the periodic table is printed on page 17 of your data booklet. So you will notice that zinc has MR of 65.4 and the sulfur has 32.1. O4, I'm just putting the 4 together to avoid conflict, 64, and that is equal to 64.4 plus 32.1 plus 64 is gives you 161.5. Therefore moles of ZnSO4 is equal to, oh wait, I did something wrong here. Oh, I didn't put this here. So it's not that, this gives you the amount of water evaporated, so I had to put the mass of the, and here I need to put 76.34 minus 74.25. 2.09 grams. Two 2.09 divided by 161.5. To 0.013 mole, right? Yeah. So mass of H2O is this one. Okay, so here they are asking you to calculate the number of moles of water. So it's 77.97 minus 76.3 for what I did first, divided by 18. We know the MR of water is 18, right? It's using 9.1 times 10 to the power of negative 2, just writing in standard form. Therefore, x is equal to 9.1 times 10 to the power of negative 2, over 1.29 times 10 to the power of negative 2 is approximately equal to 7. I'm not gonna say exactly equal. So you must know that x is an integer. X is an integer, so just make sure you give your integer answer. Just make sure you don't give you give 7 point. It actually gives you 7.05 something. Okay, so use your results to calculate x. Done above. So make sure you don't do this mistake in the exam. Done above. If you do it, just cross it out on the top and do it on the bottom. For many people, an intake of approximately 15 mg per day will be sufficient to prevent deficiencies. Zinc ethanoate crystals may be used in this way. What mass of pure crystalline zinc ethanoate would be needed to obtain a dose of 15 mg? Okay. 50 mg, right? Okay. 15 milligrams of zinc is the same as 15 times 10 to the power of negative 3 divided by the mR of zinc, which is 65.4, is equal to 2.29 times 10 to the power of negative 4 moles. So you need this much of zinc every day. That's quite low actually, but you can see that for every 1 mole of this thing you eat, for every 1 mole of zinc ethanoate, you get 1 mole of zinc. So if you want 2.29 times 10 to the power negative 4 moles of zinc, then you must eat the same amount of zinc ethanoate. So it should be 2.29 times 10 to the power of negative 4 times the mR, which is 219.4, which is equal to 0.050 gram, 503 gram. So you will ask, why don't they just serve direct zinc? Direct zinc is hard to swallow because obviously it's a metal. This one you can dissolve it in water. You see, it's mixed with water, so you can dissolve it in water safely. Another thing is that they need to increase the mass. So let's say if you are holding a few moles, about these many moles of zinc, about 15 milligram, even 1 gram, you can barely feel it, right? If you are holding 15 milligram, which is a lot less than 1 gram, okay, it's actually 66 times lesser than a gram. So your body can't feel it. That's why they need to make it a bit more, teeny bit more heavier. Okay. If the dose is taken as 5 centimeter cube of aqueous, so what I said was just shown here. They can make a syrup out of it and just give it to you. If this dose is taken in solution as 5 centimeter cube of aqueous zinc ethanoate, what would be the concentration? Of the solution used? So you will need 2.29 times 10 to the power negative 4 moles. So you need 2.29 times 10 to the power negative 4 moles in 5 centimeter cube, right? Equal to 2.29 times 10 to the power of negative 4 moles divided by 5 centimeter cube, which means 5 divided by 1000 dm cube. So of course the 1000 is moved up, so it means that I have 0.229 over 5 mole per dm cube. equal to 0.0459 mole per dm cube. Is the concentration. This is a very low concentration, so you must have no problem drinking it. So that is it for question 1. So this is took us 15 minutes, 15 and a half minutes I must say. So that is actually quite quick. So there are a whole of 5 questions. So if you took 15 minutes, we should be able to solve in 75 minutes, which is coincidentally that thing, okay? And we discussed a lot of things which you don't need to do in the exam, so you must have about 15 to 20 minutes at the end for checking, okay? So see you guys in the next video where I do question 2.